Hello all. I'd like to make up a video here for the online activity 1 report. So in the assignment section of Canvas, you'll find the file that has the background information for the report, and then at the end it has this title called graphs. It really should probably be instead of saying graphs with a hyphen, it should probably say instructions for your report. But anyway, after that it says, in Canvas, obtain Excel data file called ESCG1. That's also in the assignment area for this online activity 1, and it's the student data file. So this is what it looks like here in Excel, and you're going to do the following things to it according to the directions, and upload that into Canvas for your report. So number 1, it says enter your name in cell A1, which you can do up here. It looks like it's B3 on this one, but it doesn't matter. Put in your class number, adjust the time columns to tenths if you haven't done it already, or if it hasn't been done for you. You can easily change that by just clicking this button here, and it'll add in a tenths for your seconds. And so now we have time in seconds and concentration for some data that you have to work up for this activity. Number 2 says complete the spreadsheet. So you have to fill out these 2 columns, one for the log of concentration and the other for 1/over concentration. So we're going to use Excel, but if you don't have Excel, you can use a calculator or whatever to find these values. So for Excel, I put in equals. This activates the equation bar up here, and I want to find the log, and put in a parentheses. Then I can click this value and return, and it takes the log of that, and I can continue downward to find the log. Same thing with the inverse, equals 1/over. I'm going to have inverse concentration, return, and then I can fill down and fill out that spreadsheet. Now, it also says in number 2 of the instructions to express all values to the correct number of significant figures. So here we have our experimental data here. So supposedly that has the correct number of significant figures. These 2 columns that we just made are generated data based off of the concentration. I see that this concentration value has 5 significant figures, and so this value here for the log can only have 5. But you have to remember that a log isn't a normal number anymore. It's this weird thing. To the left of the decimal is said to be the character, and to the right of the decimal is the mantissa, and the mantissa is the one that holds all the significant figures. So I have to have 5 places after the mantissa to reflect the 5 significant figures that concentration value was derived from. So I see that this is 1, 2, 3, 4, 5, and that's correct. The concentration, 1/over concentration value only has 3 significant figures. So I have to change that to make sure that it has 5. And so I'm going to go all the way down here, and I'm going to click this to add a significant figure to all of them. So now they have 1, 2, 3, 4. I need 1 more, 5. So now they all have 5, but I got to make sure that all my values here have 5. So this has 5. That's good, 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 good. But I see it goes down to 4 here. So I have to change these to 4 significant figures. And I just go back up here and boom. So now the concentration has the right number of significant figures. The the log of the concentration, this is good. That has 5 significant figures. Remember, the character doesn't count. That 3 to the left of the decimal place doesn't count when calculating the number of significant figures for logged values. This guy here has 4, so that's no good. So I'm just going to select them all to make sure that they have 5 places after the significant figure. So that's 6. I'll go back to 5. So now at least all of them have 5. So they're correct up to here. This guy has to go to 4 significant figures. And so I need to change that. And now we're good with the number of significant figures. And we are done with number 2. And you're going to follow number 3, says upload the above is page 1, blah, blah, blah. You can follow that. Number 4 goes to construct graph of concentration versus time. And the graph should be properly titled and labeled with all the axes. And we have to look for any linear relationship that we might find. So essentially, directions in 4 and 5 tell us to plot, to make plots of the time versus concentration. So I can select that, go to insert, scatter plot, and I see there's the plot of concentration versus time. It's not linear, so I'm not going to fit it to a line. That wouldn't be logical. And then I can go and do the next one, the log of the concentration. Let me do this over. Okay. There we go. I'm going to insert this scatter plot. And I'm going to see that that's the linear one. And then I can do my 1 over and see that that's not linear. So I've done these already. I just want you to note that they have to be properly titled, and you can fool around with, putting in colors if you want. It doesn't matter. Make it plain Jane as far as I'm concerned. But this is the concentration. Check out the units on the y-axis versus time. The units are in parentheses. The one that came out linear, I'm going to have Excel fit that to an equation. I'm going to change the X and Y to their appropriate labels, namely the log of concentration for Y, and X is going to be T with seconds in parentheses. I have to make sure that my slope has the appropriate units so the equation's consistent. And for this term is unitless, so my slope times my X value have to be also unitless, this term, and then my last term is unitless. I check for sig figs. I look in my data. I see the time has 3 significant figures, and these guys over here range from 4 to 5 sig figs. So it's between 3 and 5 sig figs. This slope has 3, so that's okay. This guy over here, the intercept has 1, 2, 3, 4. That has 1 extra. So I'm going to leave that go just as Excel had printed it, because I'll give you guys 1 extra, but 1 too less is no good. So here I get a little extra information here is perfect, but if you had 0.72, then that would be an error because your data reflects significant figures between 3 and 5. So 3 is the minimum. 4 is one more, and 5 would be too much. So you're going to do that for these 3 plots. You're going to identify the linear function and plot it according to the instructions outlined in number 4 and 5 and 6. So you're going to plot all of those just like I have in that video. Then the last thing you're going to do is do a Word file. And so that Word file is going to look something like that with these 3 items that you have to address. Number 1, based on the 3 graphs that you just made from the data that you were given, you have to determine which type of reaction order this represents and why you have decided that it was that reaction order. So that's the important thing. So you're going to use this graphical method to make your plots. And we know from looking at those plots that when I plot the log of the concentration versus time, that's the only one that gives me a linear function. The other ones have curvature in them. So the conclusion is that the rate law is first order in that concentration of reactant A. Now, why did you come to that conclusion? The reason why you came to that conclusion is because of the integrated rate laws, which are discussed in the background. So you should really read the background for this online activity. And in that background, it gives you the integrated rate law for the 0th order, for the 1st order, and for the 2nd order. And you'll notice that for the 1st order, it says that when you plot the log of the concentration, the integrated rate law says that you should get a linear function when you plot the log of the concentration versus time. And so if that one comes out linear, that is proof because of association with the integrated rate law for 1st order. So you have to explain that in your own words in writing and upload that as part of one for this report. All right, in number 2, it says using the appropriate linear equation, identify the specific rate constant K for the decomposition. Carefully explain and demonstrate how you've done this. Okay, well, I see that this is the equation for the 1st order integrated rate law, right? 1st order integrated rate law. And Excel is going to fit your plot to a y equals mx, and the m here, I don't know what it is. I'm just going to guess it. You can look back at the plot. X plus some b, which I'm just going to make up here as well. So say that was Excel. So from looking at the form of the integrated rate law for 1st order, you see that the rate constant here can be identified with that number. In other words, minus K equals minus 0.0069. Therefore, K equals positive 0.0069. And so you're going to do that analysis and you're going to explain through association with the integrated rate law, you have been able to determine what K must be using the information that you got from the Excel file. And again, you're going to talk about the units and why they're appropriate for the equation. Also, um, not only are they appropriate for this equation, they also are appropriate for the rate, a first order rate law. Check it out. So if I have a first order rate law, I know that the units of K change such that my rate always comes out in molarities per second. So if it's first order, I have units of molarity coming from the concentration. So the K units only have to be reciprocal seconds. And that's what we found when we analyzed the plot and looked at rise over run for the log of the concentration versus time plot. All right, so I think that is enough hint for number 2. Number 3 says, give the form of the rate law with the order dependency, but give the values for x and k. So in other words, they want you to put it all together. Rate equals my rate constant, which I determined above to be this value with its units, times the concentration of that A to the 1 power. And now it says, explain how this would have looked if none of the 3 plots came out linear. Well, if none of the 3 plots came out linear, then you wouldn't have been able to determine K. So I don't know what that is or its units. And you wouldn't have been able to determine the X value, but you would know that in that case, X would not equal 0, 1, nor 2. Okay, that you can conclude if none of them were linear, if no linear function was found, then you don't know what K and X are. All you know is what they are not. And X is not 0, 1, or 2. So I think that should get you in a pretty good position to finish this report, I hope. Thanks for listening.